Okay, so I'm asked to graph this equation, and looking at it, I know it's quadratic because it has the term x squared, so it's degree 2. I know to graph it, every parabola is going to have a vertex point, a point that's by itself. So the first thing I want to do, before I just go throw up a t-table and start picking just arbitrary values for x, I want to find that x value of that vertex point. And it's real simple to find that x value. You just have to memorize the formula. The formula for the vertex point, I'm going to abbreviate as VP, is x equals negative b over 2a. And I know where a and b come from because we've already done this with the quadratic formula. I look at my equation, I make sure it's in descending order. A is always the coefficient in front of x squared. A is negative 1. B is always the coefficient in front of x, and b is 4. I don't need to know what c is, so I'd fill in this formula. Negative b means the opposite of our b, so the opposite of our b would be negative 4. And this is 2 times a, so 2 times negative 1 would be negative 2. And then I would do my division, and I'd get x is 2. Well, to have a point, a vertex point, not only do you need an x value, you need a y value. To get the y value, you now substitute this x number into the original equation, because the original equation says y equals. So to do this, I would write y equals negative, I replace x with 2 squared plus 4. I'll replace x again with 2 minus 4. The reason why I put this 2 in parentheses is it's connected by multiplication, 4x. The reason why I put this 2 in parentheses is to show the square just belongs to the number that's x. It doesn't belong to the negative sign. So now I'm going to follow order of operations. I'm supposed to square first. 2 squared, right here, 2 squared. This part here is 4. And 4 times a negative 1 would be negative 4. 4 times 2 is 8 minus 4. All right, negative 4 plus 8 is 4. 4 minus 4 is 0. And I would get y is 0. So now I know when I go to graph this parabola, the vertex point is at 2, 0. That's the point that's going to be by itself. Why that is helpful is now when I go to set up my t-table, I know that's the point that goes in the middle of the t-table, 2, 0. And then to get my other points that are going to be butted up, I go to the left 3 places of 2, and I go to the right. Well, going bigger than 2 would be using 3, 4, and 5. Going smaller than 2 would be 1, 0, and negative 1. And that's why you need to know the vertex point. Now that I have all my x values in my t-table, I need to get my y values. Again, to get y, I'm going to use this original equation. So again, it doesn't matter where you start working. I'm going to start with negative 1, so I'm going to write y equals negative. I'm going to replace x with negative 1 squared plus 4. I'm replacing x with negative 1 minus 4. I'm going to do my calculation. I do squaring first. Negative 1 squared is 1, and 1 times a negative 1 would still be negative 1. 4 times negative 1 is negative 4 minus 4. So that's negative 1 minus 4 minus 4. They're all negative. I would add them. I would get negative 9. I would substitute in 0. Y equals negative 0 squared plus 4 times 0 minus 4. 0 squared is 0, and 0 times a negative would just be 0. Remember, 0 doesn't get a sign. It's neutral. 4 times 0 is 0 minus 4. Well, 0 plus 0 is nothing. Nothing minus 4 is negative 4. I would substitute in 1. Y equals negative 1 squared plus 4 times 1 minus 4. I'd square first. 1 squared is 1. 1 times a negative is negative 1. 4 times 1 is 4 minus 4. Well, I know 4 minus 4 is going to cancel and make 0, so this is going to leave me negative 1. Now, here's the important thing. If these 3 y values are negative 9, negative 4, and negative 1, so should these 3 y values. So let's make sure, let's check. If we substitute in 3, y equals negative 3 squared plus 4 times 3 minus 4. 3 squared is 9, and 9 times a negative would be negative 9. 4 times 3 is positive 12, minus 4. Negative 9 plus 12 would be 3. 3 minus 4 is negative 1. What do you notice is these guys are buddied up, which that should be what happens. If this point 2, 0 is the vertex point, then the y value for this point and the y value of this point should match because they're going to be symmetrical. If they didn't match, that meant you made an error in your calculation. So now if I substitute in 4, y equals negative 4 squared plus 4 times 4 minus 4. 4 squared is 16. 16 times a negative is negative 16. 4 times 4 is 16 minus 4. Negative 16 plus 16 is 0. 0 minus 4, that's a negative 4. Did it correctly. I matched up. So when I substitute in 5, I better get out negative 9. Let's see. Y equals minus 5 squared plus 4 times 5 minus 4. 5 squared is 25. 25 times a negative is negative 25. 4 times 5 is 20 minus 4. Negative 25 plus 20 would be negative 5. Opposite signs we would subtract, get negative 5. Negative 5 minus 4 we would add because they're both negative. That would give us negative 9. We did it correctly. Our buddies match up. So when you set up a t-table for a quadratic equation, that's your goal. The vertex point goes smack in the middle, 3 values to the left, 3 values to the right, and they should be symmetrical. See you in the next video.